You know, for the longest time, everything we observed in space, well, it was part of our own solar system. That all changed with the discoveries of Oumuamua and then Borisov. And now we have a third confirmed interstellar visitor. So in this explainer, we're going to break down the incredible discovery of 3I Atlas and what scientists are starting to learn about it.
All right, here's what we've got on tap. We'll kick things off by covering what exactly makes an object interstellar. Then we'll walk through the amazing story of how 3I/Atlas was found, get into what it looks like, and see how it stacks up against its predecessors. To wrap things up, we'll look at the future of this research and some of the new protocols that are changing how these discoveries are handled.
So let's start with the big picture, right? Why is the entire astronomy community buzzing about these objects? Well, it really boils down to one of the most fundamental questions we have. What are other solar systems actually made of?
So what is an interstellar object? It's not just about being from another star system. The absolute key is its trajectory. An ISO is moving so ridiculously fast that our sun's gravity just can't capture it. It follows a path we call a hyperbolic orbit. It swings by the sun and then just keeps right on going, back into deep space. That speed, its hyperbolic excess velocity, that's the definitive sign that tells us it's just passing through.
And this slide, this really gets to the heart of why these things are so important. Think of them like cosmic messengers or maybe even fossils sent from other star systems. They formed in the swirling disk of gas and dust around another star, which means they're literally made of the same stuff as that star's planets. So by studying them, we get this incredible, direct look at the building blocks of planets way out there in other parts of the galaxy.
Okay, so now let's dive into the discovery of 3I/Atlas itself. And let me tell you, finding this thing wasn't just a stroke of luck. Nope. It was the result of a really sophisticated system that was designed specifically to spot these kinds of fast-moving, unusual objects.
The timeline here is just, wow, it's remarkable. So on July 1st, 2025, a telescope in Chile spots this faint little smudge. Less than 6 hours later, an automated alert zips out to astronomers all over the world. Within just 2 days, a whole global network of telescopes confirms its trajectory. And by July 5th, boom, it has its official name. This kind of speed is an absolute game changer for studying these visitors that don't stick around for long.
So, how on earth did they do it that fast? Well, the secret is this automated pipeline. The Atlas survey is constantly taking pictures of the sky. Then, an AI-powered system called Digest2 just churns through this mountain of data looking for anything that's moving in a strange way. When it spotted an object moving way outside the norm, we're talking more than 5 standard deviations, it automatically flagged it and sent out that crucial alert.
And here it is. This is the number that just sealed the deal. 33.9 kilometers per second. That's its speed way out there relative to our sun before gravity really starts to pull on it. It's even faster than Oumuamua and Borisov. A speed like that is just unequivocal proof that it is not bound to our sun. It's absolutely screaming through our solar system.
So, with that incredible speed and its totally unique orbital path confirmed by observatories across the globe, there was just no doubt left. The data was crystal clear. This was our third confirmed interstellar visitor.
Okay, so once we knew for sure it was interstellar, the next question was pretty obvious. What is this thing? Let's get into the initial profile of 3I/Atlas.
The very first observation started painting a really clear picture. It was faint, sure, at magnitude 19.4, but you could definitely see it had a fuzzy coma and a distinct tail. Its orbit is going to bring it closest to the Sun, that's its perihelion, in late October 2025, at a distance just a bit beyond the orbit of Mars. And that is a fantastic trajectory for us to observe because it's close enough to get a good look, but it won't get lost in the sun's glare.
Now this chart is really interesting. It shows its geometrical albedo, which is basically just a measure of how reflective its surface is. At 14.5%, 3I Atlas sits right in the middle, between the surprisingly reflective Oumuamua and the much darker, more typical comet, 2I Borisov. This is a big hint that its surface composition might be something of an intermediate case, different from the two we've seen before.
And this is a really key distinction to make. Oumuamua, the first interstellar object, was a total mystery. It just looked like a dead, inert asteroid. But 3I/Atlas, with that visible coma and tail, is clearly an active comet. That's why it got the C in its designation. It's actively shedding gas and dust as it gets warmed up by the sun.
So now, with 3 confirmed objects, we can finally start to move beyond just looking at one-off curiosities. We can actually start doing some comparative science. Let's see how 3I/Atlas fits into this growing interstellar family.
This table is fantastic. You can see the diversity at a glance. I mean, Oumuamua was fast, it was inert, it was strangely shaped. Borisov was a bit faster and looked just like a classic, volatile-rich comet you might find in our own system. And now you have 3I Atlas, the fastest yet, showing some activity, but it's more muted than Borisov's was. Each new discovery is adding another crucial piece to the puzzle, and it's showing us that there's really no single type of interstellar object.
And believe me, we are just getting started. With the next generation of sky surveys, like the Vera C. Rubin Observatory's LSST, we're expecting to find not just one every couple of years, but somewhere between 10 and 20 per decade. And AI is going to be absolutely essential for sifting through all that data to find them. We are standing right on the cusp of an explosion in interstellar object science.
Of course, this new era of discovery brings with it a whole new set of challenges and responsibilities. So finally, let's take a look at the path forward, both for the science itself and for how we talk about it.
I'm sure you remember all the wild speculation that blew up around Oumuamua's discovery. Well, this chart really shows how much the scientific community has learned about communicating these things. In the first 24 hours, about 10% of the online chatter about Oumuamua was just misinformation. For 3I/Atlas, that number was less than 0.5%, and that's largely thanks to new protocols from the International Astronomical Union that really prioritize clear, rapid communication with the public, getting verified data out fast through official channels to get ahead of any unfounded rumors.
So the roadmap from here is pretty clear. The number one goal is to just gather as much data as humanly possible on 3I/Atlas before it heads back out into deep space. Scientists will model its nucleus and composition, they'll compare it to our own comets, and they'll use everything they learn to help plan for future missions, like Europe's Comet Interceptor, which could one day actually visit an ISO up close.
So, what's the big takeaway here? We are officially moving away from these surprise one-off encounters and into a new era of systematically studying interstellar objects. By combining these incredible AI-driven surveys with open and ethical data sharing, we're building a whole new framework to truly understand these messengers from other stars. And with every new visitor, the question just gets more exciting. What secrets about the galaxy will they reveal to us next?